Let's use the graph of f to find the given limit. When necessary, state that the limit does not exist. So here's the picture, and on this page we're going to find the limit and the function value at 5. Okay, so that I can look at all of them on the same page. Let me move this. Let me copy this right next to this picture right here. Okay, so that I don't have to go up and down as we do this. Okay, so take a look at this for me. The first one. Let me highlight that first one in red. So we're looking at limit as x approaches 5 from the left. Okay, so let's first find x of 5, not -5. Okay, this is talking about approaching 5 from the left. This minus sign right there is talking about from the left, try to get close to 5. So first thing I'm going to do is find 5 on the x-axis. Okay, where is 5 on the x-axis? Right here. Here's 5 on the x-axis. Let's see what's happening at the x value of 5. So if I try to draw a straight line right here. Okay. So what we're going to do for the answer for part A is we're going to try to get to this dotted line or this point right here from the left. Okay. So start somewhere from the left of this dot. Okay. So I'll just probably start somewhere over here. Okay. I'll start right here. That's to the left, right? So if I start here and I get closer and closer and closer to that dotted line, what is the function value approaching? What is the y value of that dot, right? So let's read the y value of that dot, okay? The y value is up here, okay? So what's that? So this is 5, this is 6. Let me just get rid of this real quick, okay? This is 6 and this is 7. So it looks like if we start somewhere on the left of this graph and get really close to that dotted line of x equals 5, we are getting the y value or the function value of 7. So the first answer is 7. But you see the next one? I think it's going to be the same because we are approaching 5 from the right. So start somewhere on the right side of that dotted line, okay? And we're going to try to get really close to that dotted line at 5. Where are we going? We're going to the same dot, right? So the y value or the function value is still 7. Look, the left-hand limit, I'll write down left-hand limit, and the right-hand limit, notice they are the same, right? If the left-hand limit and the right-hand limit are exactly the same, then what we say is that the general limit as x approaches this number, this 5, is going to exist, and that equals what number? 7. See, this happened because they met at the same spot, right? The left was going to this point, a y value of 7, and this right side was also going up to the y value of 7. So when left-hand limit equals the right-hand limit, the general limit, so the green one down here is the general limit. It exists. The general limit, hold on. The general limit exists, and it equals that left-hand limit and the right-hand limit, okay? Now, let's look at the last one. The last one down here is asking for f of 5, okay? So we're looking for a closed circle at x equals 5, okay? We do have a closed circle right here, right? Now look, when the x value is 5, we did have this closed circle up at 7. So the function value is also equal to 7. Okay, now the topic that I'm about to talk about is actually for next week. But what we will do is we will compare the general limit to the function value. If these two are the same, if the limit and the function values are the same, then the function is continuous at that point. Okay. Where did that go? Where did that question go? Oh, down here. I just kind of ask you down here. Is this continuous? Notice that the general limit was equal to 7. And then the function value, the closed circle, was also up at 7. So when these two values are the same, notice they are the same, then we get to say yes. Okay? And I'll add a reason here, because limit as x approaches 5 of f of x was equal to the function value f of 5. When they are the same, we get to say that yes, this function is continuous at x equals this number 5. Okay, so we'll talk about this continuity definition more in section 1.2, but this video was more for reading the left-hand limit, approach it from the left, and the right-hand limit, approach it from the right, and if they are exactly the same, then we get to say that the general limit exists and that it equals that same value. Okay?